through yesterday some of the documents. First is the scenarios. I believe the audience who are present over here are very familiar with the scenarios because I will be using them very often. So, assuming that I am not going into the description of the scenarios, that is A and B, and their subdivisions. So I will directly come to the climatic and non-climatic fragility of Sundarbans. This section I will try to give a small introduction to the inherent fragility, inherent vulnerability, as well as those created by us. The inherent fragility, we know that, and it was discussed in the morning, that a lot of pressure is created by the human being on the ecosystem goods and services. And this is one of the main reasons, other than the environmental stresses, the cause of fragility. But there is another dimension to it. An estuarine ecosystem like Sundarbans, although Sundarban ecosystem is moderately diverse compared to other estuaries, but an estuarine ecosystem is typically rich in biomass, but not so in diversity. So when we plot the diversity against the salinity, we get a U-shaped curve. That is when we plot it from the river to the estuary and then to the sea again. So we get a U-shaped curve. That is, the diversity drops, reaches minimum at the estuarine region, and then increases in number and reaches a high value in the sea region where salinity is high. Now what happens? The narrow base of diversity makes the ecosystem less resilient to stress. Now I introduce here the concept that although the number of species are small, but a estuary typically performs more number of ecosystem services than a normal forest. For example, forest of Makuda or Purulia. An ecosystem of estuary performs render more ecosystem services. So what is the net result? A fewer number of species shouldering one ecosystem services. So the redundancy is less. There is less redundancy. If we lose the species, then there is higher risk of losing the ecosystem services as well. And such a system, as we all know, are less resistant to invasive species. Future adaptation often largely depend on ecosystem services. So we must keep this thing in mind when we frame our ecosystem adaptation options. The external stresses like high population pressure probably need not be overemphasized. Overexploitation of resources, that is, an ecosystem has a capacity to which it can supply its resources sustainably. We all know, although not quantified through the TEAB framework, but we know intuitively that we have exploited the limit in Sundarbans. The reduced freshwater supply, this is problem for western part of West Bengal, but probably it is good for the Bangladesh part of Sundarbans, because freshwater flow is towards the Bangladeshi part of Sundarbans because of the tilting of the Bengal basin. Sea level rise and progressive salinization will discuss in details. Pollution, it has been discussed by my predecessors. Look at this picture. This is called ocean color monitoring. This red color really captures the level of chlorophyll. The level of chlorophyll in the sea. You can see this part is the Sundarbans. This part you can easily recognize. Here the nutrient runoff, that is the phosphate and those things, nitrogen, that runoff into the estuarine region is very high. And this has resulted in explosive growth of diatoms in these areas, resulting turning the sea into red. The higher chlorophyll content gives the reddish color. Compared to this, the Orissa coast you will find very low red color. So nutrient runoff here is much lesser. So these all bits of space.
What I will say here is the perspective of a physical geographer, maybe partly from the geologist too. We had a lot of discussions on the salinity problem of Sundarban. Can I start with this with the perspective of a physical geographer? This is an image of Bengal Delta. You know, this is the Bhagirathi River, and this is Padma, this is the Jamuna or Brahmaputra, as you like to call. So whereas Gorai, maybe this one is the Gorai. And if we refer to the geology of the Bengal Basin, many experts have referred to the 90-degree fault and subsidence of Central Bengal. Professor Hajra knows better than me. And this has resulted tilting of the delta towards east. And if you go along the bank of the Padma, be it in the Indian part and in Sundarban, you will find the optic point of Bhagirathi, Jolongi, Mathabhanga, and so on, maybe in your part, Gorai and others. One interesting feature we find that to cope with the subsidence of the Central Bengal, Padma has incised deeply, and the optic point of Bhagirathi, Jolongi, Mathabhanga remains about 5 meters above the level of the Padma during lean season. It is only during the rising flood the water enters into this. This is the hydrodynamics of the delta. And the eastern part of the delta, so all rivers, all distributaries remain alarmingly disconnected from the freshwater flow. This is the point number one, what I like to emphasize. So if you take into account the salinity problem of this, we sometimes are very critical about Farakka Valley project. But we must be very faithful to the science. It is a mighty structure which was built in Malda. I will show in subsequent slides, no, not this one, that it is a mighty intervention across the Ganga. And a canal has been excavated, 38 kilometers long. And the total annual discharge of Ganga at Farakka is estimated to be 525 billion cubic meters. And the Farakka feeder canal can induce only 40,000 cusecs. Imagine the situation if we just withdraw the Farakka bridge and allow the entire water to go into the Bangladesh during the lean season. It will not elevate the level of the Padma more than a few centimeters. And if it elevates, that will not reach the level of that optic point. This is the hydrodynamics of the delta. We must keep in our mind that. And second thing, I would like to share with the friends of my Bangladesh, these deltaic rivers gets a base flow during the lean months. That is from the flow from the groundwater. After the expansion of agriculture and the so-called green revolution technology, so much water is being exploited from the groundwater table. The base flow has reduced appreciably, leading to total decay of the river system of the delta. With this background, and second thing I would like to share with you, whenever we talk about the deltaic river system, we take the rivers as the conduit of flowing water, but in the delta, it is the conduit of suspended sediment load too.